Hello, how are you doing? This video is going to go over the first half of Chapter 6 in a condensed form. I've taken out some of the things that are a little unnecessary and concentrated really on the things that you would need for standardized testing, like the ACT or the SAT. If you are behind, then this is what my offer is to you. I'm going to go over this document, which will take a little while because there are 27 questions on it, but it covers the whole first half of the chapter. If you follow along and copy these notes out and write them out and send them back to me, either just take a picture of them or scan them, however you can do, I will give you full credit for all of the assignments for chapter 6.1 through 6.4 so far. Then I will ask you to try to take the 6.1 to 6.4 test. I know that there'll be a couple things on that test that we haven't talked about. And that's okay. I'm going to eliminate those. Will be bonus questions. And I will just grade the ones that we went over. My hope is that, well, two things. Number one, if you're behind, you'll be able to catch up by trying to do these things in a more condensed way. And number two, if I concentrate just on these skills, you'll be ready for standardized testing whenever that happens. All right. So let's start and go over some of these things. The first thing you have to understand is what a composite function is and how it's used. What a composite function is that we're taking two functions and we're doing them together. So I have my function f and my function g and my function h. If I look at this, what this is telling me is to take, just like orders of operation, do the parentheses first, the inside. What is g of 1? Well, g of 1 is, remember, g is x plus 4. So it's going to be 1 plus 4, which is 5. So g of 1 equals 5. If I plug in a 1, I get out a 5. Now what am I going to do with that 5? I'm going to put it here. So now I'm going to find f of 5. I know that f is 3x. So it's going to be 3 times 5, which is 15. So f of g of 1 is 15. Right? Just plugging in numbers and finding solutions to them. This next example, I've got g of h of 0. So I'm going to do h of 0 first because that's what's on the inside. Well, h is x squared minus 1. Well, in place of x, I'm going to put 0. So what is 0 squared minus 1? It's negative 1. 0 minus 1 is negative 1. So I'm going to take that answer, and now I'm going to take that negative 1, and now I'm going to find g of negative 1. I found h first. Then I'm going to take the answer and plug it into g. Well, g, remember, is still x plus 4. Well, I'm going to put negative 1 in place of x. Negative 1 plus 4 is 3. So that means that g of h of 0 equals 3. Remember, two steps. I plugged in 0 to h. Whatever that answer was, I plugged it into g. That's how composite functions work. Now, sometimes we have composites of 3 functions. We're going to do all 3, but they follow an order. We're going to do g, and then we're going to find an answer and plug it into h. We're going to find that answer and plug it into f. So it's going to work this way. G of 1, remember g, x plus 4, so it's 1 plus 4. So the answer is 5. I'm going to take that 5 and now plug that into h. And remember, h is x squared minus 1. So it's going to be 5 squared minus 1. 25 minus 1 is 24. I'm going to take that 24 and plug it into f. Now f is 3 times x, 3 times a number. Well, it's 3 times 24, which would be 72. So f of g of, oops, I did that backwards, I'm sorry, f of h of g of 1. I started with 1. I ended up with 72. The 1 became a 5. Plug in the 5. The 5 became a 24. Plug in the 24. The 24 became a 72. And that's it. That's how you do composites. Let's do this here. I'm going to take negative 2 into h. That answer will go into g. That answer will go into f. So let's do it. So h of negative 2. Remember, h is this. Negative 2 squared minus 1. Well, negative 2 times negative 2 is 4, and 4 minus 1 is 3. Now I'm going to take that 3 and plug it into g. Remember, g is x plus 4. Well, it's going to be 3 plus 4, which is 7. I'm going to take that 7, plug it into f. And remember, f is 3 times the number x. Well, x happens to be 7. 3 times 7 is 21. So f of g of h of negative 2. So remember, I started with negative 2, it turned into 3. 3 turned into 7, 7 turned into 21. So the answer is 21. That's how composite functions work with numbers. Now, how do I put functions into themselves? So I'm going to find g of h, which means I'm going to take h. Here's what it means. I'm going to take h and put h into the function of g. Remember, g is 5 times something. Well, notice how it says g of x equals 5 of x. So if I put in 3, it'd be g of 3 equals 5 times 3. G of 8 equals 5 times 8. G of a equals 5 times a. Whatever I put in there, that's what it becomes. So I'm not putting in a number. I'm putting in a whole nother function. G of h of x equals 5 times h of x. Just whatever I put there. G of h of x equals 5 times h of x. Well, I happen to know what h of x is. It tells me. H of x is x squared plus x minus 1. So I can multiply that out. 5x squared plus 5x minus 5. This is what g of h of x equals. And now, what if I want to do it the other way? H of g of x. And all that dot means is that the g is going inside of h. I know that h is something squared. Well, guess what? What that something is going to be. What am I putting in place of x? I'm putting g. So look at the patterns here. Wherever there was an x, now goes a g of x. Right? And what is g of x? Well, g of x equals 5x. So when I multiply that out, 5x squared is 25x squared plus 5x minus 1. So these are called composite functions. If you have any trouble with the composite functions, go to YouTube, search composite functions. There will be a ton of videos on it, maybe something that explains a little better than I'm explaining to you. All right. Now these are not composite functions. We are just putting operations on them. We're going to first do f plus g. I'm just going to take x plus 5 and add it to x squared minus 4. That's it. Combine what I can. We'll put the x squared first, then we'll put the x. 5 minus 4 is 1. This is f plus g. What about f minus g? Well, start with f, but this time we're going to subtract this. So instead of adding them, we're going to subtract them. So if I put that negative through, all right, so the x squared goes first, then the x. 5 plus 4 is 9. That's f minus g. F times g. Here's f, here's g. I'm multiplying them together. Problem's almost done. Just got to actually, I can multiply through and simplify it, so let's do it. Little FOIL action. X times x squared is x cubed. X times negative 4 is negative 4x. 5x squared. 5 times negative 4 is negative 20. Now, just because we usually do it this way, we'll just rewrite it so the x's go down in order. And that's f times g. Lastly, I have f divided by g. So here's f, here's g. There's nothing I could do to make it any simpler. There it is. F plus g, f minus g, f times g, f divided by g. Okay? Now, a problem like this looks a little crazy, but it's really not. Remember, a function is if you put in a number, you get out another number. If I put in negative 4, I get out 3. So let's find f of g, see if it exists. So I'm going to work inside. I'm going to start with g. Now, I only have 3 points for g. So g is not a function or anything crazy. G is just these points. If I put in 1, I get out negative 4. Now I look at my f value. Is there any f value where I can put a negative 4 in? Well, here. See how these numbers match up? F of negative 4. Well, these negative 4s match up. So that means if I put those two functions together, if I start with 1, I end up with 3. Okay? It's got to work for all the points. The next point is if I put in 2, I get out negative 1. Well, guess what? That matches up here. If I put negative 1 in for f, I get out 1. So I started with a 2. I ended up with a 1. Can I see how that works? I'll show you a different way to think about it. If I put the 1 and the negative 4 there, well, which one of these points would match up with the negative 4? It'd be this one. It'd be negative 4 and 3. If I take these out, I get 1, 3. If I had 2, negative 1, well, I need a point with a negative 1. I started with 2, I ended up with 1. So if I do that for this one, 3, negative 1. Do I have a negative 1 up here? Oh, I do. It's this one. I end up with, if I start with 3, I end up with 1. This is f of g right here. All right. G of f. We'll do it backwards and see if we get anything. So we'll start with f. See if it works. Okay, and I'm going to duplicate this page. Let me just duplicate it so that I can erase this and do the next part. Okay, but in the notes I send you, it's still there, okay? All right. So let's start with f. Well, I got a negative 4. If I plug in a negative 4, I get out a 3. So now I look at my g's. Do I have a g that starts with a 3? And I do. If I put in a 3, I get out a -1. So I start with a -4, end up with a -1. If I think about the points, 1, I'm sorry, -4, 3. Down here I got a 3, -1. As long as these two match up, 4, -1. All right, -1, 1. Which means I didn't write that correctly, sorry. If I put in -1, I get out 1. Okay, does G have something that starts with a 1? Well, it does. You get out -4. Because, here I go, -1, 1. G has a 1, 4. -1, 4. Let's see if it works for the last point. F is a 2, 2. Do I have a G that starts with a 2? I do. This is G of F. Whoops, I put H. That was weird. So it's be a circle. It's not multiply. That's how those work. Now, if you have anything where it doesn't match up, then they don't exist. All right. Now it says state the domain and range of the composite function. The domain is all the x values, -4, 1, and 2. And the range is -1 and -4. You have to say -1 a second time. So the domain are these, the range are these. Same back here, I skipped that one. The domain is 1, 2, 3. The range is 3, 1, and 1. So the range is 1 and 3. The domain is 1, 2, and 3. Remember, domain is x's, ranges are y's. That's all that it ever is. Okay. Inverse functions. An inverse function is where you flip the x's and y's. That's all you're doing. You're flipping the x's and y's. That's it. So if I wanted to graph this function, I'm going to graph it with a table of values. I'm not going to worry about any kind of slope intercept y because I'm not supposed to be anything like that. I'm just going to pick 3 numbers for x. Okay, and I can tell you right now they're not going to fit. So I'm going to pick 3 numbers for x. I'm going to multiply them by 3. -1 times 3, 0 times 3, 1 times 3. I can graph those. -1, -3 goes down here. 0, 0 is here. 1, 3 is here. There's my line. Let me draw it. And let me fix it, because that's not very good. Okay, that's close enough. And tell you what, we'll make it blue because that's the color of that. Now an inverse is just these numbers flipped around. I'm going to put -3, -1. 0, 0 is going to be 0, 0. And 3, 1. I'm just flipping the points around. Now let me graph them. -3, -1, 0, 0, 3, 1. Now I've got myself a line that goes like this. And the thing about an inverse function is when you look at them, it's like if you folded it along this line here. If you were able to take this on a piece of paper and fold it along that line, that red graph and blue graph would match up perfectly. That's an inverse function. Just flip the x's and the y's. Let's do the same thing. Let's do it like a table. Okay, let me just see. Yeah. So, okay, let's do number 9. Let's do it a different way, not as a table. Let's actually do the inverse. So remember, this is y equals 2x minus 1. Now you know how to graph that, don't you? As far as y equals mx plus b. Well, you have the y-intercept of -1, and the slope is 2. I go up 2 over 1, up 2 over 1, up 2 over 1. Just goes like that way forever. So this line, oops, I don't want to do that one. I want to do a solid. So this line right here, after I fix it and make it look right, looks like this. Okay, and we'll make that line red. Now, how do I do an inverse a different way? Okay, here's how you can always find an inverse. An inverse is you just flip them. You just take that x and that y and you just switch their positions. That's all you do. Then you solve this equation for y. Let me add 1 to both sides. And now let me divide by 2. So y is going to equal x plus 1 over 2. Now you got to graph that. Now graphing that, think of it this way. If you're graphing it, remember it's a line. You just need a table. So could I just pick a couple x values and graph it? Sure. Let's make a quick little table. Pick some values. Sometimes the easiest way to graph is just going back to the very basics you learned a long time ago. I'm going to pick 1. If I pick 1, what's 1 plus 1? It's 2, and 2 divided by 2 is 1. So I have the point 1, 1. I'm going to pick 3. And the reason I'm not picking 2 is I don't want any halves. I don't want any fractions. 3 plus 1 is 4. 4 divided by 2 is 2. So I go over 3. I go up 2. And let's see, what do we go out to? Well, let's go to negative 3 just because. What's negative 3 plus 1? Well, negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. I got this. So let me draw this line. See what we end up with. I did that pretty good the first time. Let's just change that color and see what I end up with. Whoops, and I messed up. I'll try to fix it. Okay. See? Inverse functions always kind of cross anywhere along this dotted line, this diagonal right here, okay? I said dotted line, probably should draw it. Right? Just that y equals x 45-degree angle line right there. Flips right over and makes a perfect reflection. So inverses make reflections. That's what they do. You just change the x's and the y's. Here's how I like to find the inverse. I'm just going to write as y equals x minus 1. Now I'm just going to flip the x's and the y's. Everything stays the same. Just flipping these two. Now I want to solve it for y. I'm going to add 1 to both sides. So if I have this equation, this is my inverse. Guess what? That's not what that says. So no, these are not inverses of each other. All right. What about these two? Okay, I'm going to start with this one. I'm going to switch the x's and the y's. Then I'm going to solve for y. I'm going to subtract 3 from both sides. And then I'm going to divide both sides by 2. Well, guess what? Another way to write this is this. Are these inverses of each other? Does this equation match this equation? It does. They are inverses of each other. That's how you do an inverse. Okay. Graphing this function. Square root of x plus 2. Don't do anything fancy. Let's just pick points. An easy one. We want ones that's easy to take the square root of. Okay? Well, what's the square root of 0? 0. 0 plus 2 is 2. And you're going to see all these graphs have the same shape. Square root graphs look like this. 1, it's a nice easy one. What's the square root of 1? 1. And what's 1 plus 2? 3. I think there's one more easy one to pick. Let's pick 4. Because what's the square root of 4? Right? 2. 2 plus 2 is 4. So I put in 4. 1, 2, 3, 4. And I think I can do a 9. I think I have just enough room. Why 9? Because 9's a square. What's the square root of 9? 3. And 3 plus 2 is 5. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay. 1, 2, 3, 4, 5. So it looks like that. So what's my domain? My domain are all my x values. I can start at 0. So x is greater than or equal to 0. It's everything 0 and above. This goes on forever that way. Now what about the y's, up and down? If I'm going up, where does it start? What happens to start at 2? And then it goes up to 3, 4, 5. Guess what? It's going to go 6, 7, 8. It's going to go up forever. So this is your domain and range. Okay. Let's keep going. It's going to be a square root function, so it's going to have this shape. But the thing is, it's a negative, so it's going to be flipped upside down. But that's all right. Let's take some points. Now in this case, 0 won't be nice. In fact, it'll actually be impossible. Because 0 minus 1 is a negative number. I can't take the square root of a negative number. I got to start with 1, because what's 1 minus 1? 0. What's the square root of 0? 0. What's 0 times 2? 0. So I'm going to start with x is 1 and y is 0. Then we'll go to 2, because 2 minus 1 is 1. What's the square root of 1? 1. What's 1 times negative 2? Negative 2. So 2, negative 2. 3, 4, 5 is a good one. Probably the last one I can do, because 5 minus 1 is 4. What's the square root of 4? 2. What's 2 times negative 2? Negative 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Yes, 6, 7. Oh, I can do 9 again. Oh no, 9 is not good enough. I had to do 10, because 10 minus 1. Anyway, as long as I have a couple points. Oh, sorry, that didn't work out really nice. This shape looks like that. All right, domain and range. See how, where does the x's start from? They start at 1. And they go on forever. 1, and they go on forever that way. The range, the y values, remember they start here at 0, but then they go down forever. So y has to be less than or equal to 0. That's your domain and range. All right. And you can plug them into an equation. All right. I'm going to take that equation and plug in what we know. Here's what we're given. We're given that v is 70. So I'm going to put 70 in place of v. Okay. V sub 0 equals 8. So that's squared. 8 squared. And we don't know h. So 64 plus 64h. So now we just got to solve for h. So a couple ways we can do it. Probably the easiest way would be the opposite of a square root is a square. So if I square both sides, 70 times 70 is 4900, 7 times 7 is 49, and this is just what it is. Subtract 64 from both sides. So what do we get? 4836 equals 64h. Now I'm going to use my calculator. I'm going to divide by 64. So 4836 divided by 64 gives you approximately 75.6 feet. So the coaster is only 75.6 feet high. That's not very high, but that's okay. That's how you solve it. All right, simplify. Simplify means take out as much as we can. Some of them are easy. What's the square root of 81? Well, it's 9. You got a 0.9, because 0.9 times 0.9 is 81. There's your answer. 324. Sometimes the answers don't work. Like I'm going to do square root 324. Oh, cool. I get 18. Nice. Ooh, the sixth root of 64. That might be new. And remember, sixth root, because you know how square roots are two numbers multiplied by themselves. 18 times 18 is 324. 9 times 9 is 81. We have a sixth root. What number can you multiply 6 times together and end up with 64? And the answer is actually 2. I'm going to show you why this answer is 2. I'm going to take 64. I'm going to break it up into its parts. 2 times 32, which is what? 2 times 16, which is 4 times 4. I can break all these up. So notice what I have. I got 1, 2, 3, 4, 5. I got 6 2's. I used to talk about something called radical jail. That if you've got a sixth root, it takes 6 of these to get out. Because what's 6 divided by 6? It's 1. And 2 to the first is 2. Okay, that's how you simplify radicals that are not that have roots also. Okay. Fifth root. Now sometimes you can do these on your calculator. Now if you know, that'd be great. So on your calculator, look for something that says x or something like that. On the TI-84, you have, if you hit math, then you go down to number 5. If you hit a 5, you can type in the roots. Like I can put a 5 on the outside, and inside I'm going to put a negative 1024 divided by 243. And if I make it to a fraction, I end up with 4/3. Now, you can use your calculator, but you can't always use your calculator on the ACT test. So it's kind of important to see how these break down. Now I'll show you how to break it down with this one. So let's take a 243. Anything you can divide 243 by? Actually, it's a 9, because 2 plus 4 plus 3 is 9, so you can divide it by 9. So 243 divided by 9 is 27. 27, well, first the 9 breaks down into 3 and 3. The 27 is 3 times 9. And that 9 is 3 times 3. So how many 3's do we got? 1, 2, 3, 4, 5. So if I write this, I got 3 to the 5th power times x to the 10th power. I divide everything by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. That's how you break them up. Square root of negative 14a squared. Now, the square root and the square cancel each other out. Remember, if we don't put a number up there, we assume it's 2. What's 2 divided by 2? It's just 1. This answer is 14a. Alright. Alright. Let's see if these work out or not. 16. Well, do you know what the square root of 16 is? Yeah, it's 4. Do you know what the square root of m squared is? Remember, it's 2 out here. 2 divided by 2 is 1. We have 1m. Square root of 25 is 5. And it does not matter that it's in the denominator. You just do each one separately. Okay? Now here's one that's not going to work out as nice. Let's take 64. Let's break 64 down. Didn't we do 64 before? We did 32 before. It doesn't matter. Let's go. No, we did 64, didn't we? 64 was, there it was, 2 to the 6th power. Let's use that again. All right. So some things might stay, some things might get out. Let's see. Let's see if anything stays. Let's start with the negative. Oh, well, guess what? Negative doesn't get out. 2 to the 6th. 6 divided by 3 is 2. Okay, they get out. R squared. Oh, there's not enough to get out. You need 3 to get out because 2 divided by 2 doesn't go into 3. That stays. W to the 15th. 15 divided by 3 is 5. Nothing is a remainder. So it's 4. W to the 5th. The cube root of r squared. And I lied a little bit. A negative does come out. Because remember, if you have a cube root of a negative, it means you got 3 of them. So you have a negative. That's your answer. So it kind of does follow a nice little pattern. You just divide. You just divide. If you can take your whole number and put it into a power, just divide. All right, 2x to the 8th. Well, there's a 2 out here. What's 8 divided by 2? 4. Multiply that through. That's what I get. So simplifying radicals really has to do with the root out here. If it's a cube root, 3's come out. Groups of 3. Now in a group of 3, you stay. Now this is not on the sheet, but I just want to give you one so you can see how this works. W, X, Y, Z. There. Let's say we're doing that, okay? This actually is a very, very easy problem because you just take their exponents and you divide by that one. What's 8 divided by 4? 2. 7 divided by 4. How many times does 4 go into 7? Once. But what's your remainder? So it's like you took 4 of these out, which means 3 are left. 15 divided by 4. 4 goes into 15 3 times. 4 times 3 is 12. So it's like I took 12 of those out, which means I got 3 left. If these numbers are less than that number, they can't get out. 4 goes into 5 1 time with 1 left over. How we write this, we just don't bother with the ones. So we'll do w squared x y cubed z. And what's left under the radical? X cubed y cubed z. That's how you do these. All right, and lastly, these are all calculators. Just plug it on your calculator and figure it out. If you're not sure how to do a root, a 4th root or a 5th root, look it up, depending if you've got, again, if you've got an 84, it's just math, and it's the 5th option down. So these are just strictly calculators. 7.8. Whoops, there's 3 decimal places. So 2.793. 89. There's a negative on the outside, so that stays 9.434. The 4th root of 25. So again, I just do math. Whoops, hold on, let me do that. So math, go down to the 5th option, Put a 4 on the outside, a 25 on the inside. I get 2.236. And the same thing. Math, fifth option down. Put a 5 on the outside and put a negative 4 on the inside. Negative 1.3120. Okay, that's a condensed lesson. Excuse me, I know there's a lot of stuff thrown in there. Look at it piece by piece. These are the important things that you need to know for the first half of Chapter 6. So, good luck to you. I'll talk to you soon.